All right, hello everybody. I'm Jacob. I am a product manager for Oculus. As was mentioned, I'm kind of a browser guy. So I'm here at this front-end development conference, and of course I've had my hand at building plenty of web experiences over the years. But like for the last decade or so, I've been living on the other side of the fence, building platforms, building browsers, building web standards, which actually gives you a weird different form of imposter syndrome. It's hard to keep up with everything you guys are building, but I'm going to give you a perspective from a platform developer about how we think browsers are advancing for new types of devices, in particular virtual reality, augmented reality. I did start out as a web developer. I interviewed at Microsoft, thought I was going to do a web development job. They told me the day of my interview it was for the IE team. I told them I used Firefox. That was awkward. But actually, that was what they wanted. Of course, you know the way this story goes. Eventually, they also paid me to help shoo it off into the pasture. But actually, along the way, Microsoft kind of regained its involvement in open web standards and open source through things like Docker JavaScript engine, and I was involved with a bunch of that stuff. And I found my way into becoming kind of an input geek. So one of the web standards I worked on was pointer events, which was all about emerging types of input modalities. So touch was becoming big, but there were things like Apple Pencils and Microsoft Surface Pens and Kinects and Leap motion controllers and all kinds of stuff. And that's where I kind of fell into this niche of building web standards for to bring the web into new and emerging types of devices, which is why it makes sense that I'm now at Oculus doing this for VR. And that's really a pattern that we've seen, right? The web has been at the forefront of device types all along the way. So the PC it had its rise with the internet and the web. And, there's a computer in every office and in every home, and the web is largely to thank for that. Smartphones, right? Remember the iPhone originally launching with no app store. The web was front and center for apps and experiences on that device. Then they got bigger, and we started doing tablets, and the web had already figured out something that apps in these app stores hadn't, which was responsive design. So yet again, the web was there to kind of lead the front for these devices. Gaming consoles, smart TVs. You might not realize it, but a lot of the TV and movie streaming applications that you watch are actually web apps. So it stands to reason that the web's going to play a central role in VR. I'm going to tell a little bit about how that's true through the lens of some Oculus devices, but this is true across all VR and AR devices today. It didn't take long for Oculus to realize it needed to build a browser, not just any browser, but one that was tailor-made for virtual reality. I don't know if you saw the cool little line art retro animation there, but if you watched Michael's talk yesterday, I got so excited because he had this similar retro cool gaming Tron-esque intro to his talk, and I was super jealous and realized I was missing one key thing, and that was a cool soundtrack. Whoa, now you're awake. All right. So, with that, now you're a little bit more awake. So what is Oculus Browser? You might not be surprised. It's a Chromium-based browser. If you've ever talked to Awesome Man PPK, he gives us the label Chromia, the mini Chromium flavors of Chrome. But unlike a lot of Chromium flavors, it's not just a reskin. It's actually heavily optimized for Oculus hardware. We're doing a lot of advancements in the WebXR standards and WebGL APIs, as well as enhancing the media experience, because media watching in VR is huge, and performance is critical therein. So you might think of Unity or Unreal when you think about building content for VR as kind of the center place. And that's actually how I thought about it when I joined Oculus. I thought that was where most of the time spent, or the most popular applications were in VR. And actually, if we look at through the lens at least of Oculus Browser, we find out something quite different. Amongst the Oculus Go device, which we shipped earlier this year, a fairly accessible price point, standalone VR, doesn't require a phone or an expensive PC. If you look at the monthly active users of that device, over 2/3 of them are active Oculus browser users. And so you might think, okay, they're just needing to log into something or they're checking stuff. Actually, there's a ton of time spent. People don't want to take the headset off just to check Gmail or go to Facebook or watch YouTube or browse Reddit or find cool things to do in VR. And so it turns out that it's also one of the most popular applications by time. So the web is a big deal for these devices. And it's not just 2D websites like you use on your phone or your tablet or laptop, but of course also in VR and immersing in full 360. We see an incredible amount of time spent in these immersive experiences from web, which is also fairly surprising because it's an early standard. In fact, it's evolving very quickly from what was called WebVR into a new spec called WebXR, which broadens the capabilities to consider scenarios like mixed reality and augmented reality in addition to VR. So despite it being fairly emerging in the standard space, there's a lot of content and time being spent on the web. There's this fundamental problem, though. Even though devices are getting lighter and better optics and better battery life and no tethers connected to PCs, and the user population is growing, but they still are a fraction of the total web's users, right? And so this can make it hard to justify from a development perspective. And there's kind of this chicken and the egg problem because at the same time, growing the users is dependent on having a lot of content available as well on those devices. So how do we break through this tension? And we think there's several ways that we can to help move VR forward. The first is investing in frameworks. There's a number of great frameworks already out there for developing in 3D graphics, like 3JS or WebVR, through A-Frame or Babylon. We build one. You might have heard of React, but we build one called React 360. Which is meant for a narrower set of use cases and making it super easy to build content for VR without being a 3D graphics expert. In fact, I'll show a couple different experiences that have been built on top of this that are pretty awesome. This is the National Gallery Museum in London. It was fairly inexpensive to go in, capture stunning high-resolution 360 photography, import that into React 360, write a little bit of React code to facilitate some interactions and moving about the space. And you get this experience where from thousands of miles away, you can be in the National Gallery too. Oh, and not just visit it, you can also learn more by seeing annotated info cards on different artworks and exhibits. Super cool, super inexpensive, really easy to build because we're making it possible with frameworks. But another way to leverage or break through this chicken and egg problem is to start leveraging phones. You saw this a lot with AR and magic window experiences. The same is actually true of VR. You can build using VR technologies and 3D graphics technologies for phones and leverage the scale of billions of users. So this same National Gallery experience also runs on a phone through React 360, broadening the value proposition for building such an experience. So I actually have the same video you saw yesterday, and this is really relevant. I think it's magical. I'm going to show it again for context into this next piece of technology that we're working on. But this is Walt Disney's multiplane camera.
The different elements in the scene were separated according to their varying distances from the viewer. This put the moon on a plane farthest away from the camera. With our original picture broken down in this manner, it is possible to control the relative speed with which each individual part of it moves to or away from the camera. But the moon remains absolutely still, and so it will always remain the same, neither growing nor shrinking in size. Of course, our cartoon camera does not shoot sideways, but is placed above and shoots downward toward the drawing. Since this new camera used many planes, we called it the multiplane camera. And here now is our same moonlight scene the way the multiplane camera sees it. As you can see, we finally got the moon to keep its proper distance.
So you're seeing a theme here. I like really dramatic music. Actually, we're going to make that possible without a huge rack of cameras stacked high with the camera on top of it and planes that move up and down. We're going to do it with the one in your pocket. Starting out with dual camera phones. So this experience is available for iPhones, the XLs, the iPhone 10, and we'll expand to other cameras in the future. But we're enabling those billions of users to make user-generated content that's awesome in VR. So this is an experience we call 3D photos. So we leverage the dual focal lengths of these camera phones to actually create a depth map. And from that depth map, we can create a 3D mesh. And from that mesh, we'll run it in WebVR and WebGL in order to create an engaging experience that gives you a sense of presence and a sense of the moment that no traditional photo can really do. And it works on a phone. But put on a headset, and it's truly magical. You can actually look around the photo frame as if it was just a window. And it's super neat. Like, I've actually seen people look at moments, memories, and you can just see this like visceral reaction from them of like, wow, it's like they're taken back to there because of the presence and the depth that this content provides. So how does it work? This is a look at behind the scenes of one of these photos. So you have a traditional RGB image that your camera takes on the left. From the dual focal length cameras, we can create a depth map. This is a grayscale representation of it. So white would be the farthest away in the image, and black would be the closest level in the image. And we can combine those two things using some computational photography algorithms to produce something that looks like this. So we do some fills and whatnot to create a layering and parallax effect in the image. Oh man, I'm hungry. Speaking of food, I thought these donuts were really cool. Jessica was kind enough to take a cool 3D photo up here on stage. So you can check that out if you're friends with her on Facebook. But it's not just photos. Like, you actually haven't experienced memes until you start to play around with 3D. There's an exciting community that's building around this that's pretty fun. But even more practical, we're seeing people experiment with this through ads and marketing. So this is an Aquaman poster, movie poster. And what's kind of startling from this is that this tech has really only been launched in the public for a few weeks. And it was intended to just work with your iPhone, take a photo and upload it. But people were quickly figuring out how to manipulate it and generate synthetic photos. So this works by taking the RGB image into Photoshop. You can add layers with text levels, and then also take that depth map and alter it as well. So you provide, like, say, a constant gray level for a text block, and you can make it float in the middle of the scene like you see here. And it makes sense that they're trying this even without instruction or aid or real support from the Oculus side, because it's super engaging. Like, you know, on Facebook in this example, you're scrolling through the feed, and like you see photo and video and text and photo and video and text, and then all of a sudden you see this thing that moves and draws you in, right? So it's a super rich way to leverage the technology of VR, but for other devices. But the real insight here is that we're getting people to build a lot of content that is awesome in VR, right? So if every one of these cameras can take one of these photos, and we can produce millions of these photos, there's really cool experiences. It gives you more meaning as a user, more value to buy one of these devices. And that's how we're going to help, one of the ways we're going to help bootstrap VR as it heads into the mainstream and as the technology and hardware matures. But as a developer, if you start to leverage this pattern of developing for 2D, we create a new user problem, which is if I have a headset and I see something on my phone, how do I then get it into my headset? We created a new problem there. The web is well positioned to solve this. Turns out links work really well. Turns out typing does not in VR. So we're still experimenting with this. This is largely an unsolved problem, but a very basic example of something that we're exploring is if you've seen like the headset icon that says View in VR if you own a headset. What if, when you're not in VR, there was such an icon that said Save to VR, and you could take something that you see on the web, maybe either through an extension or through an icon overlay or a framework, you could essentially save that to your headset and experience it later. So that's something we're going to work on and build. Once you're in VR, how do we help you discover content? So we've been toying around with a new tab page in Oculus browser that's purpose-built for discovering VR content, both from like your friends as well as from the open web. These experiences jump you directly into WebVR, which is traditionally something you can't do. It usually requires user interaction, and I'll talk about that in just a second. But if you're building for VR and you're interested in getting more exposure to users, please do talk to me. We're happy to help get your content to a lot of people. This is one of the tricks. This is like the only actual line of code I have in this entire talk, which is, but I did it for a reason, which is solving for one of the pieces of friction in VR, which is you have to have user input to jump into VR. So if you want to call a request present, that requires per standard user input to jump into VR. There's really good reasons for that, in particular security, but also just user experience. We don't want to jump you into another world without it being something you were expecting. In instances like that new tab page, though, we know that's what the user wants, and so we want to give you a way to jump straight in. So there's a VR display activate event. We'll call you in instances where we're confident that the user wants to go directly into VR. You can request the display presenting service and start rendering to VR. For those that aren't as exposed to the VR space, I'll talk about a couple basic terminology. So 3DOF, or 3 degrees of freedom, represents being able to track motion in the form of orientation. Roll, pitch, yaw. So this is with a headset. This is I can look around in a 360 space, like in that National Gallery Museum. Or with a controller, I can rotate my wrist and point at things and click it. But what I can't do is move about in that virtual space. And that is known as 6 degrees of freedom. So that adds lateral movement forward, back, left, right, up, down. Traditionally, this is done with cameras. So if you use an Oculus Rift or an HTC Vive, you can get the external cameras that track the headset. They're somewhat cumbersome because you have to set them up. And so new devices are coming out, the Oculus Quest, as well as the Lenovo Mirage Solo, that have inside-out tracking that allow you to explore the virtual world physically, actually moving around and not just looking around. So this is an example of what that can look like on the web. This is Mozilla's Hubs experience. You can put on, this is a prototype of the Oculus Quest. You can walk around, it tracks your motion, you've got full leverage of your hands, so you can reach down and pick something up, you can throw something. You can draw in this case, I pick up a marker and draw. But it's the web, so you also get all the other cool standards. So this is using WebRTC, you can talk to your friends, you can have multiple people in a room and interact in a virtual space, regardless of distance. Just a side note, this is actually really hard to capture these experiences. So what we did for that was we took a headset and we strapped it to the camera. And then that way we could capture real life footage as well as virtual footage from the virtual environment. And as we moved it around, it was from the same vantage point. So if you ever needed to capture a cool product demo or whatever, that's a cool trick to try. Like the other experiences, though, Mozilla is leveraging the same strategy. This this content also works on a phone. What's different here, though, is it's not about content that works on a phone or VR. It's content that works on a phone and VR and can connect people between those. So it's something the web is uniquely positioned to do that, say, Unity or native applications will have a harder time building. Because the web just runs on all these devices already and with the same code. It's effectively a version of progressive enhancement. The same content works good on a phone, and it works great in VR. So some tricks. This is an early space. Every new device comes with its tricks of the trade. The iPhone came around, and we had to realize that our buttons had to be bigger, and that what's the gesture language for interacting with it. Same kind of thing exists for VR, except we're just in early days, so we're learning some of the basics. So some of these things might seem intuitive, but trust me, they're actually not the first time you go to build for some of this stuff. This is kind of a misleading point. So I said, usually there's fast Wi-Fi. It's a bit of an assumption, but because of native applications being pretty large, like you go install a VR applications, it can be gigabytes even. Users tend to have good Wi-Fi connections and they're strong. But this is where the web's going to win, because eventually, if these devices go mainstream, it will face the same problems that every device does. You'll have challenges with internet connection and whatnot, and that's largely an unsolved problem for VR, given that 360 videos and things like that are really large file sizes. But for now, when you're prototyping and developing, one of the nice things is that you can typically bet on fast Wi-Fi. The browsers are also fairly modern. There's not a legacy tail here, so you're going to get a good baseline level of support, so no IE to support here. Which is cool. And your 2D content will actually work really well. Don't not think about, oh, that's confusing. Your 2D content will get used in VR. And it's important to try out that experience. But largely, browsers take care of this fairly well. Even input works well. These fancy motion controllers and things like that ultimately get mapped to mouse events, touch events, as well as gamepad controllers and pointer events. So that's the good news. Interesting things to consider for VR specifically. You have to design for mobile-grade performance. And you may have tried out earlier devices, things like the Oculus Rift is attached to this super powerful gaming PC, and you're like, I've got all the cycles in the world. But really, the scale here is on the mobile end. Lots of people have, even something basic like a Google Cardboard that you drop your phone in, and so that's a big challenge. It's hard enough to get good web performance when rendering in 2D. Rendering in 3D is an even bigger challenge, as well as at the high frame rate that's required. And why that actually matters, and why I call that out, is it's less acceptable in VR to drop a frame or two. And the reason for that is that VR motion comfort can actually really vary. What might feel good to you at a decent frame rate might not feel great to someone else. And so you need to try it out on different users. And it's a new form of how users react with your content. I mentioned earlier, text input is cumbersome, so anything that you can do to reduce the times that people have to enter text in your application is going to be beneficial for VR. And the future here is probably better support for voice recognition or hand tracking and virtual keyboards. But today's state of the art is pretty cumbersome, so think about ways that you can reduce the friction there. And I mentioned low frame rates can cause user discomfort for some folks. This one's less intuitive. Avoid white backgrounds. That's a big problem for the web, given it's the default. Why is that a problem? All right, I didn't bring a prop with me, but I wish I had. All I want is a bright flashlight, and I'm going to just shine it in this guy's face right here, and he would probably tell you why a white background in VR is a pain. Yeah, you've got a screen close to your eyes, and so if you can avoid solid white backgrounds, that's actually probably for the better. Accessibility. This one's also, interestingly not intuitive for some folks. But you know what? If you're an advocate for accessibility, you know exactly what I'm about to say, which is Designing accessible interfaces actually always pays dividends no matter what device you're going for, and that's still true with VR. If you're designing large, easy-to-hit, accessible targets, that's really good for VR. It turns out that trying to hit something off in 3D space with a laser pointer or with crude hand tracking that exists today is a challenge. And so making that larger and easier to hit is a good thing. High contrast is actually quite helpful, but avoid white. High contrast is helpful actually to overcome some of the aliasing and distortion effects that exist with lenses in VR. So you might be tempted because it's cool and you can float 3D text off in the distance transparently, floating by in Star Wars form, but actually sticking a background behind it and giving it good contrast generally will reduce eye strain and improve the perceived quality of the experience. Design it for your parents. Now, I don't know. I don't know your parents, but the thing about VR is it's new to everybody. Nobody's figured out the interaction language. Not everybody's figured out how the controller, input mechanisms should work and what the patterns should be there. So provide helpful hints, helpful context, good guides along the way to increase confidence in using your experience. So all these tips will help. Play space. We don't generally have to think too much about the physical elements of how people interact with our websites, other than I think touch was the first time we had to really start thinking about that from how big are my buttons and that type of thing. But for VR, obviously people are going to play this in their space, and they might be upgrading their devices, but they're not upgrading their living rooms. As 6 degrees of freedom becomes the future, we have to design around what will work for a lot of people. We've done a lot of different studies. We've gone into people's homes, take photographs, measure things. 2 meters square is about the right target to satisfy a lot of users. You should have an experience that allows people to go much larger than that. At a recent event, we did a arena scale VR event where you were in a 4,000 square foot facility and you could just roam around in VR. But most people don't have an arena at home. So also less intuitive, and let me tell you, the first time I built a web VR application, I built a basketball game. You can throw basketball hoops. And that's when I learned VR is actually 3-dimensional, not 2-dimensional, and ceiling fans are a problem. So 2 meters above you as well, although I think there's probably some folks that already bypass that just by putting the headset on. So 6 degrees of freedom is the future of all these devices, but we actually believe that a lot of people will continue to use these devices in a seated position. They'll stay on a couch or in a chair because it's comfortable. There's a lot of people that want to watch YouTube videos, and you don't need to be walking around your living room to do that. So developing experiences that can transcend both full motion in a space as well as a seated 3 degrees of freedom experience is really good to accommodate those users, and it also broadens your accessibility to users of different motion abilities. Sound. Sound is too often an afterthought. For good reason, we've been trained on the web to really try and avoid it. We've built features into browsers that autoplay sound and keep it from being intrusive. But sound actually adds another level of presence in VR that can often overcome some of the shady things you might be doing to get good graphics quality. Ambisonic sound is sort of like surround sound, but surround sound is just forward, back, left, right, and ambisonic sound is actually in a spherical space. Luckily though, we don't need new standards to do this. Web audio is fully capable of downmixing this into binaural audio, and that's super. You could do an entire talk on this. I'd actually love to do that someday. But for now, I'll point you at these 2 open source libraries that are pretty awesome, JS Ambisonics and Google's Omnitone, that help you take a sound and place it in your environment and add that level of immersion. People ask about what the DevTools experience is. Turns out the web's also really mature here. Another place that we're leveraging the strengths of the web. Chrome DevTools, Firefox DevTools, they're great for developing in VR. You get that nice, change a line of code, you can refresh it. A lot of this stuff will just render directly in your browser window on your laptop, so you don't even have to put the headset on. But when you do, you can just connect it over USB and run a command like ADB reverse that allows you to forward your local server to the device, and you can get that tight development loop there. And since Oculus Browser, by the way, is Chromium-based, the same Chrome DevTools work from your laptop with Oculus Browser. Just put the headset in developer mode. So let's talk about the future. WebXR, as I mentioned, is replacing WebVR and broadens the scenarios and the capabilities of the technology. This is super new. The Immersive Web Working Group was just created like a month ago. There was a community group incubating this before. We met there a few weeks back, and we showed a prototype of some technology we've been using on the native side in VR that we want to bring to the web through WebXR, called Timewarp layers. So let me explain what Timewarp layers are. So your basic game loop, right? You run some logic, that executes on the CPU. Eventually that produces out a model that the GPU then renders to buffers. For VR, you take the head pose, the orientation of the head, and you use the compositor on the GPU to transform and distort the buffers according to the head position and the lens distortion. If that goes well, it looks just like this. Chances are occasionally it won't go well, and it'll look like this, where you blow your frame budget and you drop a frame, right? All right, on a phone, no big deal, don't sweat it. In VR, that's a problem, because what happens when you drop a frame really is that the GPU driver just re-renders the previous frame. Well, in VR, if your head has probably moved since the last frame, and if we just re-render the last frame exactly the same way it was before, it'll produce a judder. And if you go back to the VR comfort I was talking about earlier, that can actually really be disturbing for some folks. So we need to overcome that. A clever solution to this is, in the case that you're going to drop a frame, we could actually, in parallel on the compositor, go ask for the latest updated head pose, and then just transform the last frame to account for your new head position. We can do this in parallel and transparent to your application, wins for everybody. But what's cool, but what we've started to figure out is that a lot of people have realized that putting content in VR around a geometry like a cylinder is actually really nice. So like, for example, if you want to do text or UI, if you're going to put it on a cylinder around you, it makes it equidistant, so the text is legible, it overcomes the distortion of the lenses, and so it's a good experience. Well, if we actually could expose to the underlying compositor the notion of these layers on geometries in your virtual environment, then the compositor would actually be able to sample from those layers, and as it does that time warping process, it can account for the parallaxing and movement of the content, and this results in like a true breakthrough in clarity. So if you ever tried older VR headsets and thought that the experience wasn't clear, a lot of aliasing or color separation, that type of thing, part of that was display technology back in the day, but a huge part of that was not having time warp layers. So we've been using this in React VR, which is the native side of React 360. All the first-party Oculus apps, Oculus TV, Oculus venues, et cetera, are all built in React VR. And you'll notice they have like a just absolutely breathtakingly different level of quality due to this technology. That technology also reduces eye strain, which means people will spend more time in your content. So this is one of those points where I just tell you to look under your seat, and everybody magically has an Oculus headset that I've given you, and you can try it out, and you're all going to go, whoa, this is super cool. On this screen up here, you're not going to be able to see a difference, so don't strain yourself. But on the left is an image taken without time warp. There's some subtle blurring, aliasing. The text is just not that legible. It looks like your glasses are just slightly off. And on the right is with time warp, where the clarity is pronounced different. But Unfortunately, I couldn't give everybody a headset, but I did film somebody who tried out this before and after experience, and this was their reaction. I'm kidding. You'll just have to trust me, or come find me afterwards and I'll give you a demo. There's a clever revelation that we had, though, from building this, which was this actually could potentially solve what has been a much asked-for feature in VR, and browser makers have just done that weird thing that, like, so just say no, and you're like, why? And you're like, because of reasons, or security, or blah, blah, blah. I think Miles actually covered really well some of the challenges of the platform makers have in facilitating what seem like obvious solutions. And this is, can I just render my HTML in VR? Can I just like go stick it out there and just give you like coordinate space and whatnot? Like here's my HTML element, and just like here's a layer, here's a cylinder. I want to put it on there. And the answer has been repeatedly no, largely for security reasons. Timewarp layers actually give us the potential to define layers in your application that are also tied to origins. So we can start to enforce like origin protection, just like you have with iframes and other documents on the web in 3D space, which then satisfies some of the security concerns, allowing us to maybe make it possible to just define, say, a cylinder layer pointed at an element or an iframe or a URL, and render that in virtual space without having to understand WebGL. This could be super cool. Not a real thing yet, but something we have an eye towards. Another challenge in VR, again, I've talked about the performance challenges. Well, you actually have to render twice, right? You have two eye buffers, a left and a right. And the sad part is they're almost identical. They're just slightly different transforms to account for your interpupillary distance and to create the depth. Well, if you have to do this, there's double the overhead and the GPU and the drivers, and that's not a good thing. Modern GPUs, though, have an extension that can account for this, and we want to expose that to JavaScript through WebGL. So Oculus Browser has an experimental implementation. Firefox has an experimental implementation of a feature called multi-view, which basically allows that to be done in hardware in parallel and improve your performance. If you're writing a CPU-bound application, this can actually result in almost 50% reduction in CPU, depending on the characteristics of your application. This is a huge win that'll start to allow applications to hit their frame rates and deliver a nice experience for users. Another technology we've been working on is what we call fixed foveated rendering, which is a fancy way of explaining that, well, ultimately we're taking a 2D image and we're stretching it out over an arc. Okay, well, if we looked at that arc, let's see here, if this works, yeah. Okay, so if this was the 2D image, then here you've got a small number of pixels that ultimately get stretched out over a wide part of the arc. But over here on the edge, you've got a lot of pixels that then get shrunk down on a smaller part of the arc. What that means is that actually in VR, the center part of your display has the least density of pixels, and the outer edges of your display have the best density of pixels. But that's weird, because this is where I'm usually looking, and my peripheral vision is usually where I don't need as much clarity. So a trick that we can do is actually to break down the rendering regions into tiles. Your GPU actually tends to render as a tile renderer, so we can actually say in certain segments of the display, let's render at lower resolution intentionally. So in this graphic, this is like the most intense version of fixed foveated rendering, where red is half the resolution, green is a quarter, blue is an eighth, and magenta is a 16th. You might say like, oh, well, why would you willingly decrease the resolution? It turns out this is not very perceivable, and it's a huge performance win. You get the full resolution in the middle, and then it degrades as you go out to the outside. There are other techniques to foveating rendering, and in the future you might be able to use like gaze tracking and things like that to optimize this even more. But this is a big win for performance as well. The nice thing about this is this isn't something that we have to go drive into standards. It's something we're going to get for free. So, looking at now and later, like, let's recap. Like, we're leveraging 2D. We're making it really easy for you to leverage 2D. and build a bridge from existing devices that people will continue to use into AR and VR. You can free your experience by starting to explore 6DoF, but we want you to continue to work and develop experiences for 3DoF because we think that'll continue to be a modality people use VR. And we're going to help you optimize for clarity and performance through features like Timewarp, multi-layer, FFE. There's others here that I haven't even mentioned. John Carmack has all kinds of crazy ways of optimizing performance and quality through things like chromatic aberration correction and the like. But we only have 45 minutes today, so I covered some of the major ones. But the biggest thing you should take away is that Magic Glasses are coming, and the web's going to be at the forefront of those devices as well. So thank you.
Wow, thank you, Jacob. Do you want to come and take a
Sure.
seat for a couple of minutes? I think
I've been looking forward to this so I can work on my core.
exactly.
Balancing.
Yeah, I've never been in better shape
Yes.
than after a couple of days of this, which is tragic but true. So I think that's it's amazing to see this becoming a reality, so to speak. I think you mentioned at one point the expression bootstrapping VR. Is that kind of the play here? Is the intention to kind of ease people into the experience and kind of the social, get past their kind of social awkwardness of experiencing VR with the devices they have, in the aim that they'll be much deeper into it later on?
Yeah, I think that today's applications perhaps reinforce that notion of like I go away and I put something on my face and I'm in my own world.
Yeah.
But actually, what we find is that it has the potential to unlock the inverse. So if like who here works remotely on projects or through open source, right? Like we've got a lot of folks, right? So imagine for a second that you could actually co-locate yourself together in an environment. So you all put on a headset and you actually work side by side. You have a shared whiteboard and you go up and you write on it together.
Yeah.
Right? So it has the potential to actually be a more social engaging experience than outside of VR.
Yeah.
And so that's one of the types of things we're exploring.
Yeah, I mean, it feels like there are so many kind of behavioral things that we're so used to that every time we can kind of chip away at it, it's probably the wrong expression, but expose us to other things that we get comfortable with. It just kind of expands the possibilities, right? And I was kind of interested to see, so I wasn't aware of React 360 at all, and it feels like frameworks, seems like that's maturing quickly.
Yeah.
And do you see those as tools that help to like close the gap, kind of bridge the gap between web developers, people with web development skills, and like the 3D kind of development needs that you have, or is it just trying to like make use of the technologies that exist?
So I think that, especially in the early days of VR, it was a development platform that was largely accessible to game developers, the crowd that had really strong 3D graphics experience. And so part of the frameworks, the part of the motivation behind them is just to like making it accessible to a larger class of developers.
Right.
But it extends beyond developers. Eventually, like there's actually a company called Visor that has made an editor that actually allows you to it uses React 360, but it allows you to do like the National Gallery experience by just like drag and drop. And so like that's where I think ultimately this stuff can go for some class of users.
Yeah.
But yeah, it's all about developer ergonomics.
Sure. Yeah. And you mentioned that National Gallery example again. When I saw that, first thing I thought was, I mean, it looked amazing, but I was instantly thinking, God, that seems like a ton of work, not just in developing it. And I know that the tooling's getting better to make that easier to do, but in terms of the assets, like the actual capturing of the assets and like, I don't know, grading them, making them all appropriate. It feels like that's a big chunk of work, but it sounds like you're hinting at trying to make that easier as well.
Yeah, I mean, so if you go and watch, there's some YouTube videos from sessions at Oculus Connect, but there's work being done at all levels of the stack here, including the cameras themselves.
Yeah.
But there's actually a lot of companies out here that provide these services that are pretty inexpensive. I have a coworker that was able to get his apartment in San Francisco photographed in 360. Same company that did the National Gallery experience for $350 US.
Right.
So it's not a super hard thing to do or super expensive thing to do compared to other types of design and visual asset creation.
Right. Okay. Yeah. That's impressive. And you were even going like a step further than that with like the technology you were showing there for I think it was the 3D mesh.
Yeah.
And capturing things that blew my mind. Capturing things with the camera that you have in your pocket. That didn't. I mean, I know you showed that right after the multi-plane camera example. But was that actually using planes? Because it looked like there were roughly a gazillion planes, if that's the case.
Yeah.
Or how does
so
that
the
work?
actual output of this is just a standard GLB 3D asset, and it's actually a mesh. So in theory, you could rotate the whole thing around and see it from the side. We don't let you do that in the user experience because we don't have enough data to actually do you didn't take your phone around it and film at all angles. So we're interpolating and creating fills behind it and whatnot.
Right.
It's kind of like if you use Photoshop as like the content-aware fill kind of thing.
Yeah.
But ultimately, yes, it is actually a full model. If you open up the dev tools, you can actually see the model get downloaded and you can go play around with it.
It's amazing. I can't believe that these are the things that we have in our pockets now. And like that interpolation you just mentioned, that seems to be a theme that you mentioned again later on with the drop frames. So I was back there, so I couldn't hear in perfect clarity the exact details. But that sounds incredible to me. That's an option to fill those dropped frames by interpolating between the two and computing what that should be. There's like a reality polyfill. That's just kind of insane to me. I can't believe that's a thing. But surely that puts a huge burden on the resources available in the device you're using. So are there ways to detect that, and then is it an all or nothing kind of experience?
I mean, ultimately, you should be in charge of your frame rate, and all the classical approaches here to reducing your frame budget and optimizing this, like using low poly assets and things like that will help. But what we've tried to do with basically all the examples I showed, and even some that I didn't, like chromatic aberration correction, is we're trying to actually leverage hardware. So that generally speaking, the performance overhead of this stuff is negligible.
Yeah.
And in fact, we develop custom hardware or use sometimes abuse hardware on the device to pull this off with low overhead.
Right.
One of the advantages of building your own hardware.
Right. Yeah. Right. Sure. And you used an expression that I wasn't expecting you to use. It's one that I love, and it was progressive enhancement. I'm a big believer in progressive enhancement, but I never in my wildest dreams thought that would be a concept that you would be embracing here. Where is the baseline for that? I mean, what can you enhance from?
Yeah, I mean, I think fundamentally, if we can avoid the initial pattern that we had on the web, where it was like we started to just build a completely separate web for mobile, and
Right.
I think if we can avoid that pattern for VR, that's probably a good thing. On the one end of the spectrum is these like fully immersive virtual experiences where you're trying to recreate a world. If you Ready Player One kind of stuff, right?
Yeah.
The other end of the spectrum is like. Well, of course, just a 2D website. But imagine, like, maybe we go add a simple line of CSS or HTML attribute that lets you just specify the 360 environment that you're in while browsing your website, right? You go to Wikipedia, you go look up Copenhagen, and like you're looking at a 2D website, but that website told the environment to set this 360 photo around you, and you can live out that experience. Right, like that would be an example of just like lighting it up in VR without having to go the full deep end. But we want you to build at every point on that spectrum.
Nice, yeah. Well, I mean, I'm really excited. This is something that is coming to like a web environment, and some of the principles and like the strengths of the web are able to kind of shine through there. It's fascinating to hear from you on that. So thanks ever so much again for a great talk, Jacob Rossi, everyone. Thanks, Jacob.
Thanks a lot.
Thank you.